Hello guys, welcome back to my channel DP Design, and in this video we are going to learn about the steps. Okay, so in steps, for now I will create the another model. Okay, let's say create another model 2. Okay, you can apply the model name as well, you can rename it, like if I want to apply the cantilever. Okay, so it will showcase like that, and you can do the multiple operations over here. So for now I will go to the model 1 and go to the step 1. Okay, so there is no steps other than the initial means 0. Okay, you can consider 0 for now. I will explain how to apply the steps or what is the increment, so like that you can do. Okay, so first if you create the steps, so there will be multiple options. Multiple, what type of simulation you are going to perform. Okay, so there are multiple options are there: coupled, temperature, displacement, thermal electrical, structural. Cyclic is there, direct cyclics, but there has been some limitation. It is not the fatigue simulation, it is having some limited cycles in that, so you can do the simulation accordingly. For now what we required static general. Okay, so RIX is also a different simulation. We will explore this later. And for now, static general is the requirement of our step. Okay. So when you go to the step, there is one table has been created over here. So what the table means? Okay. So in the basic, there is a time period which will be keep it as a 1. 1 means complete simulation, 0 to 1. Okay. Now if you go to the NL geom, means non-linear geometry. Okay, non-linear simulations. If you have inputted the parameters like stress and strain data, and some other data which is like plastic strain you have applied, so in that you can select the option on. Okay, so if you do not have the nonlinear properties or nonlinear material, so you have to keep it off, and you can see what has been written. This setting controls the inclusion of nonlinear effects of large displacement affects subsequent steps. Okay, so if you have the data, then you can keep it on. Otherwise, for the simple simulation which is following the Hooke's law, so for that you have to keep it off. Automatic stabilization, I will keep it off, that is not necessary for this kind of simple simulations. In the increments, now it is the main part you have to learn. Okay, now coming to the parts, increments, maximum number of increments, you can keep it as a 10 lakhs, 1 lakh, whatever. Okay, it will finish the simulation under 100 increments only. But for the safer side, if you have, if Abaqus is facing some errors or some undercuts, okay, so for that you have to keep the larger number so that your simulation will not stop by the constraint of the number of increments. Okay, now coming to the, just listen to this, the important is the increment size. Okay, now I will explain you in the paint so that you can better understand. Okay, so let me create a line. Where is the line? Let me draw one line. Okay, this is 0, this is 1. Okay, so 0 means your simulation has not been started, and 1 is your completion of simulation. So what software will do, just understand this. I'll just, okay. Now if you keep it 1, so what will happen, it will directly jump onto this part. Okay, the whole, like you have applied the 1000 Newton, then it will apply in the one go. So your simulation might fail. If your simulation is very complex, then it will not work. So what you have to do, let's say I'm giving it a 0.5. Okay, so what will happen, it will create one increment over here, means, okay, so it will jump like that and like that. Okay, so jump will be in a 2 steps, and your load also will be lesser than that. Okay, so accordingly your load also will be applied. Okay, now coming to the lesser number of increments, the lesser number of increments means if I'm applying the 0.1, then only 10% of load will be applied. Whatever, if you have a 100 Newton, then only 10% of 100 Newton meter it will be applied from the 0.1 increment. Okay, so what will happen? It will create 0.1, 0.2, 0.3, 0.4, 0.5, and this will how it will go dhire dhire. Okay, slowly it will go and complete the simulation very smoothly, and it will give you the accurate results as well. Okay, so lesser number of increment size will be good, and the undercuts uh, expectation will be less if you have the lesser number of increment size. Okay, so whenever I am doing the complex simulation, what I am doing, okay, so I am keep it as a automatic, because if your simulation doesn't require a small number of increments, okay, so what the software will do, it will directly jump if it is passing on the point 1. Okay, so what it will do, it will directly jump on the point 4. It is if it is on the automatic, because the maximum number of increment size is the 1, so it can also directly jump from here, but minimum size I have told the software that start from 0.1. So what will happen, it will start from 0.1, and accordingly it will go slowly, and it will increase the increment size gradually if it is not showcasing any error or any undercuts. Okay, so like that it will happen. So let's suppose it is completing in the 4 increments. Okay, so number of increments will be 4. So maximum number of increments is more than 1000, so it will not affect the simulation. And minimum number of increment, let's say your simulation is just a minute. Let's say your simulation is has faced some error, like this is the point 1. Okay, so what it will do, there is a undercut, okay, in the point 1. So what it will do, it will it will jump laser. Okay, let's say it will go for the 0.05, and it can go up to how much minimum increment, up to this much, 10 raised to minus 5. Okay, so this is how, but it will increase the number of increments. Okay, so that's how you have to keep the minimum increment according to your requirements, according to your simulation preference. Okay, so it will come by the experience, okay, while you are doing the simulation, so it will come automatically. Okay, so I'm keep it is as a step 1, and also you can rename that by whatever, if it is loading condition, then load you can apply. So steps is being created. Steps mean nothing but what type of simulation you are going to do. Okay, so multiple steps you can select, multiple steps you can create for the simulation according to your preference. So that's how you can create the step and see what simulations requirement is necessary for this. Okay, so that's how you can perform. And that's it for the video. If you like the video, keep supporting, keep sharing, and keep learning. Thank you.